Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Math 223, final examination, term 232. Let us solve the exam together. First question, choose the correct answer. Multiple choice questions. The system with augmented matrix has how many solutions? Well, this is an augmented matrix, so the variables are here, for example, x and y, and the right-hand side is here. So the first equation is x plus 2y equals 1. And the second equation is y equals 2. And the third equation, 0 equals to 0. 0 equals to 0 is okay. If I replace y equals to 2 in the first equation, I'll have x plus 4 equals 1. And this means that x is 1 minus 4, which is -3. So there is a unique solution. X is -3 and y is 2. So there is one solution, and the correct answer is C. This is A inverse and this is B inverse. Find A, B, all inverse. Well, there is a formula that says the inverse of AB equals B inverse times A inverse. So I need to multiply B inverse times A inverse. If you multiply A inverse times B inverse, your answer will not be correct because multiplying matrices is not commutative. So 1 times 5 is 5, plus 3 times 2 is 6, so the answer is 11. I can see from here that the correct answer is B. If you want to continue, -1 minus 6 is -7, and -5, and here 1, which is exactly B. The area of the parallelogram determined by these two vectors. The area is the parallelogram is given by the norm of U cross B. This is the area of the parallelogram. So let us find first U cross V. So 1, 1, -2, this is U, and this is V. How to find the cross product? We cover this one. 1 times 2 is 2, minus -1 times -2 is 2. So 2 minus 2, that's 0. So U cross V it's a vector, and the first component is 0. The second component, cover this one, the second column, and multiply. 1 times 2 is 2. -2 times 2 is -4. So plus 4, because 2 minus minus. So the answer is 6, but we write it here -6. And then cover the last one. 1 times the last column. 1 times -1 is negative. 1 times 2 is 2. So -1 minus 2, and that's -3. So this is the U cross V. And the norm would be square root of 0 square, -6 square, -3 square. So 36 plus 9 is 45, and the correct answer is part A. These are the standard matrices for the operators TA and TB. Then the standard matrix of, well, the standard matrix of TB circle TA is equal to the standard matrix of TB times the standard matrix of TA. So it is B times A. A is the standard matrix of TA, and B is the standard matrix of TB. So I need to multiply TB. Again here, multiplying A times B will not give you the correct answer because multiplication of matrices is not commutative. 2 times 1 minus 12, 2 minus 12 is -10. From here, immediately you can see that the correct answer is number 4. But if you want to continue, -4 minus 3 is -7. 2 plus 4 is 6. And -4 plus 1 is -3. So it's okay. Two vectors. The vectors are orthogonal with respect to the weighted inner product. So I have four weighted inner products, and these two vectors will be orthogonal with respect to which one of them? If I start by A, finding UV, the inner product of U and V, using this would be half times. This is U1 and this is U2. This is V1 and this is V2. So 2 times 1 times 2 plus 2 times 2 times -4. Well, this is 1 minus 16, not 0. Orthogonal means the inner product is 0. So it is not the first one. Usually, if I have question like this, I'll try the last part. I'll go from the last. So let me try the last one. 2 times U1 times 1 times V1 plus half times U2, which is 2, V2, which is -4. This is 4. This is -4. It's 0. So the answer is D. Uh, please try B and C. Let us do it. Let us try B and C to make sure that our answer is correct. If we try B, 4 times 1 times 2 minus U2, which is 2 times -4. Well, here it is 8 plus 8, so it's not 0. C, 4 times 1 times 2 plus 2 times 2 times -4. This is 8. This is -16, not 0. So the correct answer is D. UVW vectors in a vector space. T is a linear transformation for which I have TU, TV, TW. What is T of this? Well, since it's a linear transformation, then T of this is equal to 2 times TU. I can take 2 out and distribute the T, minus 3 times T of V plus 4 times T of W. Well, this means 2 times TU is given, which is 1, -1 and 2, minus 3 times TV, which is given 0 and -3 and 2, plus 4TW, which is given -3, 1, and 2. So the answer is 2, -2, 4, plus I'll multiply the -3 inside. -3 times -3 is 9, -3 times 2 is -6, and okay, multiply the 4, -12, 4, and 8. So 2 plus 0 minus 12 is -10. -2 plus 9, 7, plus 4 is 11. 4 minus 6 is -2 plus 8 is 6. So that's the answer. This is part 6. So what is the answer? A. The distance between the point and the plane. Well, if the point is has coordinates, let us say x0, y0, z0, and this is a x plus by plus cz plus d equals 0, then the distance is given by this formula. The absolute value of a times x0 plus b times y0 plus c times z0 plus d over the norm of a square plus square root of a square plus b square plus c square. And this would be A is here is 1. 1 times 3, so that's 3. 1 times 2 is 2. Negative 2 times negative 2 is 4. And this 4 should be here, so it is minus 4 over square root of 1 square plus 2 square plus minus 2 square. So the answer is 5 over square root of 9, which is 5 over 3, and this is part C. The standard matrix for the reflection operator about the y-axis. When we reflect a point about the y-axis, what happens? This point will come here, y will not change, but x will change. So this transformation takes the point xy to a negative xy. So what would be the standard matrix? Here I have x and y. Look to the first component. Coefficient of negative x is 1. There is no y. Second component, there is no x, and coefficient of y is 1. So this is the standard matrix, and it is B. So B is the correct answer. Consider the bases B and, okay, B for R3. Let T, so this should be single. Consider the bases B, okay, for R3, and T is transformation, linear operator, defined by this, okay. So T of U1 and T of U2 and T of U3 are given. Find T9, 15, and 9. So here I have a basis for R3. And I know how T, which is the linear operator, works on the basis. So I know that T takes U1 to this one, U2 to this one. And now I need to take this vector in R3, where it's going to be. So the way to answer this problem is first to write 9, 15, and 9, which is a vector in R3, as a linear combination from U1, U2, U3. So C1, 1, 2, 1 plus C2 times 2, 9, 0 plus C3 times 3, 3, 4. And if you know how to solve this by calculator, you can do it. You will have a system C1 plus 2C2 plus 3C3 equals 9, and 2C1 plus 9C2 plus 3C3 equals 15, and C1 plus 4C3 is equal to 9. You can solve this system by the calculator if you like, mod 5, 2, or by any method, and you will find that C1 is negative 15, and C2 is 3, and C3 is 6. You can check your answer even for the first component. Negative 15 times 1 plus 3 times 2, that's 6. Negative 15 plus 6 is negative 9 plus 18. 3 times 6, 18 minus 9 is 9. So the first component is correct. After you solve, after you write 9, 15, 9 as a linear combination of U1, U2, and U3, now you can find T of 9, 15, 9. It would be equal to C1, which is negative 15, times T of 1 to 1, or U1, plus C2, which is 3, times T of this vector, which is U2, plus C3, which is 6, times TU3. So it would be negative 15 times. TU1 is given, it's 1 and 0. TU2 is given, it's negative 1 and 1. And TU3 is 0 and 1. So I'll have negative 15 and 0 plus negative 3 and 3 plus 0 and 6. And the final answer would be negative 18 and 9. So this is the final answer. This is question 2. Question 3. M22 have the standard inner product, sorry. So you know how to find the standard inner product on M22. You multiply 1 times 2 plus minus 1 times 0 plus the corresponding interest. Determine whether the vectors u and v are linearly independent. Well, u and v will be linearly independent if c1 times u plus c2 times v equals 0, 0, 0. If this system has a unique solution, which is c1, 0 and c2, 0. So we will have a system here, c1 plus 2c2, this is the first component, equals 0. Negative c1, 0c2 equals 0. So from here, I know that c1 is 0. And from here, immediately, 2c2 would be 0 or c2 would be 0. So this implies that c1 and c2 are zeros. But let me check the last equations. I'll have 3c1 minus c2 is 0. 0 minus 0, 0, so that's correct. And finally, I have negative 2c1 plus 4c2 is 0. 0 plus 0 will be 0, so that's correct. So the only answer, c1 and c2 are zeros. So this means that u and v are linearly independent. Determine whether this vector is in the span of u and v. Well, this vector will be in the span of u and v if I can write w as c1 times u plus c2 times v. So I'll have 1 minus 4, 1 and 6 equals c1 times u. I can multiply c1 immediately, but it's okay. 1 minus 1, 3 minus 2 plus c2 times v, which is 2, 0, minus 1, and 4. Okay. Let us solve. I have a system c1 plus 2c2 is equal to 1. And negative c1 plus 0c2 is equal to 1. So from here, c1 is negative 1. And from here, negative 1 plus 2c2 is 1. 2c2 would be 2, c2 is 1. I'll check the other two equations. So 3c1 minus c2, is it equal to negative 4? 3 times negative 1, that's negative 3 minus 1, it's negative 4, correct. The last equation, negative 2c1 plus 4c2 should be equal to 6. c1 is negative 1, so this would be 2. 4 times 1 is 4. Correct. So that's the answer of the system. So W can be written as negative U plus 1 times V. So W is in the span of U and V. Find the cosine of the angle between the vectors U and V. The cosine of the angle, and let us call it theta, is the inner product of U and V over the norm of U times the norm of V. How to find the inner product? I multiply 1 times 2, negative 1 times 0, 3 times minus 1, negative 2 times 4, negative 8. So 2 minus 3 is negative 1, minus 8 is negative 9. So the inner product is negative 9 over square root of times square root of norm of U. Well, norm of U, this is U. It would be square root of 1 square plus minus 1 square plus 3 square plus minus 2 square. So it's 4 plus 10, 14 plus 1, 15. So it is square root of 15. And finally, norm of V would be 2 square, negative 1 square, 4 square, 17, and 4, 21. So it is the square root of 21. So this is the cosine of the angle between U and V. Find the distance between U and V. To find the distance between U and V, I need to find first U minus V. So it would be a matrix 1 minus 2 is negative 1. 3 plus 1 is 4. So here, negative 1 and 4. Minus 1, minus 2, minus 4 is minus 6. So minus 1 and minus 6. Now the distance between U and V is the norm of U minus V. So it's the square root of negative 1 square plus negative 1 square plus 4 squared plus negative 6 squared. So it would be 16 plus 36, 40, 52, 54. The answer is 54, square root of 54. Find parametric equations for all least square solutions of the linear system. Parametric equations, least square solutions. Confirm that all the solutions have the same error vector. Find the least square error, squares error. This is chapter 6. Okay. So I need to write this system in the form AX equals B. So A would be minus 1, minus 2, 1, coefficients of X, coefficients of Y. This is A, this is the coefficient matrix. Times X, which is X and Y, I have two variables, equals 3 to 1, this is B. So first step, I write the system in the form AX equals B. And then I find the associated normal system, which comes by multiplying the both sides by AT, the transpose of A. So let me multiply AT by A. So I'll have ATA here. Okay. Let me find ATA. So AT would be the transpose of this one, negative 1, 2. First row, you write it as a column. This is A transpose times A. Well, this is 2 by 3, 2 rows, 3 columns. This is 3 by 2. So the answer would be 2 by 2. Negative 1 times negative 1. Negative 2 times negative 2. 1 times 1. So the first number is 6. Negative 1 times 2. Negative 2 times 4. 1 times negative 2. So 2, 8, 10, negative 12. 2 times negative 1. 4 times negative 2. Negative 2, negative 12. We know that the product should be a matrix, symmetric matrix. So these two numbers should be equal. Finally, 2 times 2, 4 times 4, negative 2 times negative 2, so 24. So this is AT times A. And I need to find AT times B. So I'll find it here. So AT times B would be negative 1 to negative 2, 4, 1 and minus 2 times B, which is 3, 2, 1. This is 2 by 3. This is 3 by 1. So the answer would be 2 by 1. Negative 3 minus 4 plus 1. Negative 7 plus 1, that's negative 6. 2 times 3, 6. 4 times 2, 8. Minus 2, this is 12. So the associated normal system is 6. This is AT times T. 6, negative 12, negative 12, 24 times X and Y equals to negative 6 and 12. This is called the associated normal system, and it has a solution. So let us solve it. If you try to solve it by calculator, if you try to solve it by calculator, it will say math error because he said parametric equations here. So this means that this system has infinitely many solutions. So let me solve it using Gauss and Jordan. So this is the augmented matrix, 6, negative 12, negative 6, and negative 12, 24, and 12. You notice if I multiply 2R1 plus R2, then R2 would be zeros. 12 minus 12, negative 24 plus 24. And I can divide R1 by 6, so I'll have 1, negative 2, and negative 1. So I have one equation, x minus 2y equals minus 1. And then x would be 2y plus 1. X has a leading 1, y doesn't, so y is 3. So I let y equals to t, then x would be 2t plus 1, and t is any real number. So this is the solution. This is the parametric equations. Okay, this is the answer of the first part. Now, least squares solutions for all least square. Yeah, that's it. Confirm that all the solutions have the same error vector. So this is the answer of the first part. Now the second part, what is the error vector? What is the error vector? The error vector is the vector B is the difference between these two. B minus AX. Okay, B minus AX. So that's the error vector, B minus AX. So B is 3, 2, 1. and a times x the solution, or x is the solution that we find, x and y. So a, let me write it, -1 to -2, 4, 1 and -2, that's a. And x is the solution we found, x and y. We found that x is 2t plus 1 and y is t. So I'll have 3, 2, and 1 minus. If I multiply this times this, I have here 3 times 2, and here 2 times 1, so I'll get 3 times 1, similar to this. Okay. So -1 times 2t plus 1. That's -2t minus 1 plus 2t. So these will be cancelled and I'll have here -1. Now the second row times the column. -2 times 2t is -4t. -2 plus 1 is -2. Plus 4t cancels and I'll have -2. The last row, 1 times 2t plus 1 minus 2t cancels and I'll have 1. So the answer would be 3 plus 1, that's 4, 2 plus 2, that's 4, and 1 minus 1 is 0. So that's the error vector. And here he says, confirm that all the solutions have the same error vector. Because t canceled, there is no t anymore. So this is the same error vector for all solutions. Finally, find the least squares error. Okay, this is the error vector. X is, oh, there is a mistake here. This is 2y minus 1. I wrote it plus 1. So 2t minus 1. Only in calculations, but everything is. So let us multiply. -2t plus 1 plus 2t. So these cancels and I'll get 1. And -2 times 2t, -4t plus 2 plus 4t. So I'll have 2. So I multiply 1 times 2t minus 1, -2t, so I'll have -1. And then the answer would be 3 minus 1, 2, 2 minus 2, 0, 1 plus 1 is 2. That's the error vector, and it's the same for all solutions because there is no t in it. And finally, the least squares error is the norm of b minus ax. So it's square root of 4 plus 0 plus 4. So it's square root of 8. This is the least squares error. Values of the matrix. I solve the equation determinant lambda I minus a equals to 0. So lambda minus 0 minus minus 1 minus minus 1 minus minus 1. Lambda minus 0 is lambda. and lambda minus 0 is lambda. So this is lambda times I minus A equals 0. Now solving this determinant, I'll have lambda here. I'll expand using the first row. So erase the row and the column. I'll have lambda 1 lambda. And then minus 1 times erase the column and the row. And then finally plus 1, this one. Erase the column and the row equals 0. So I'll have lambda times lambda square minus 1, the determinant. Lambda minus 1, the determinant. 1 minus lambda. I can see that I have lambda minus 1 here and here, so I'll take lambda minus 1 as a common factor. I'll have here lambda times lambda plus 1. So taking lambda minus 1 as a common factor, I have lambda times lambda plus 1 because lambda square minus 1 is lambda minus 1 times lambda plus 1. Minus, I took lambda minus 1 as a common factor. And here 1 minus lambda, I took lambda minus 1, so there is another minus 1 equals to 0. So I have lambda minus 1 times lambda square plus lambda minus 2. And if you factor, you will have lambda plus 2 times lambda minus 1. So in fact, I have lambda minus 1 to the power 2 times lambda plus 2 equals 0. So the eigenvalues are 1 and negative 2. But notice that 1 is repeated. Find bases for each eigenspace of A. So let me start by lambda equals negative 2. To find the eigenspace, I solve the equation lambda I minus x as minus A as a matrix times the vector x equals the vector 0. So lambda here is negative 2, and this is lambda I minus A. So in this matrix, I replace lambda by negative 2. So I'll have negative 2, 1, 1, 1, negative 2, 1, 1, 1, and negative 2. This is the matrix, the coefficient matrix. I need to use Gauss and Jordan to simplify it. So I will take this to be, this row to be the first row. So I'll interchange row 3 and row 1. And then I'll multiply negative row 1 plus row 2. So negative 1 plus 1 is 0. Negative 1 plus minus 2 is negative 3. Negative, so 2 plus 1 is 3. Now 2r1 plus r3, 2 minus 2 is 0. 2 plus 1 is 3. Negative 4 plus 1 is negative 3. You notice that if I add row 1 and row 2 and row 3, I'll get zeros in row 3. And I can divide row 2 by negative 1. So I'll have 1 and negative 1 here. And I can stop here. Okay, or I can make this 0. Let me make it 0. So I'll have 1, 0, 0. How to make it 0? Negative R2 plus R1. So negative 1 plus 1, that's 0. And 1 minus 2 would be negative 1. So this is the matrix times x, which is x, y, z, the variables. Okay, I can call them x, y, z, equals zeros. This is it's a homogeneous system. What would be the solution? The equations are x minus Z is 0, multiplying the first row by the first column. Then Y minus Z is 0, and Z is a free variable. There is no leading one, so Z is T. So the solution would be X is T, Y is T, and Z is T. So X, Y, Z would be equal to T, T, T. And if you take T as a common factor, so you will have T, 1, 1, 1. So the basis here consists of this vector, which is 1, 1, 1. He said find the basis. So this is the basis. If he asks about the dimension is 1. Now what about lambda equals 1? I'll have, in this case, 1 instead of lambda. So I'll have 1, 1, 1 everywhere. And if you use Gauss and Jordan, the system will be 1, 1, 1, and zeros here, because negative R1 plus R2 and negative R1 plus R3. So times X, Y, Z equals zeros. So I'll have only one equation, X plus Y plus Z equals 0. And only here X is basic variable, Y and Z are free variables. So I'll call Y T1 and Z T2, and then X would be negative T1 minus T2. And then X, Y, Z would be negative T1 minus T2, and Y is T1 and Z is T2. If I take T1, so I'll have minus 1 is the coefficient of T1 in the first component. 1 is the coefficient of T1, and there is no T1 in the last component. And taking T2, the coefficient of T2 is negative 1. There is no T2 here. So the bases consists of these two vectors. And the dimension of the eigenspace here is 2. Give a geometric description of each eigenspace of A. Corresponding to lambda equals negative 2. This is the eigenspace. X, Y, Z equals T times 1, 1, 1. Basis is one vector. Well, this equation, X, Y, Z equals T times 1, 1, 1, represents a line through the origin. We studied this in chapter 3. Through the origin, parallel to the vector 1, 1, 1. This is the equation of a straight line through the origin parallel to the vector 1, 1, 1. For lambda equals 1, now this is X, Y, Z equals this. Well, this is an equation of a plane. It's a plane through origin parallel to two vectors here, negative 1, 1, 0, and negative 1, 0, 1. Find an orthogonal matrix P that diagonalizes A. Well, the matrix that diagonalizes A, I have 1, 1, 1 from lambda negative 2. And when lambda is 1, I have these two vectors, negative 1, 1, 0, negative 1, 0, 1. But this matrix is not orthogonal. I need to make it an orthogonal matrix. To make it an orthogonal matrix, all the vectors should be orthogonal, and orthonormal. Orthogonal means their inner product or their dot product here, standard inner product is 0. There is a theorem that says that vectors from different eigenspaces are always orthogonal. So in fact, this 1, 1, 1 should be orthogonal to both of these two. Let us check. -1 plus 1, 0, correct? And -1 plus 1, 0. So 1, 1, 1 is orthogonal to both of these two. But these two are not necessarily orthogonal. If you multiply, the dot product is 1, not orthogonal. So to make them orthogonal, I'll use Gram-Schmidt. I'll take V1 to be the first vector, which is -1, 1, and 0. And I'll take V2. If I call this U1, U2, V2 would be U2, which is -1, 0, 1, minus the projection of U of V1, of U2, projection of U2 along V1. So it's in fact the inner product of U2 and V1 over the inner product of V1 and V1. This is V2. Please, you need to check the Gram-Schmidt if you don't recognize these computations. So U2 multiply by V1, -1 times -1 plus 0, so that's 1. And V1 times V1, negative square root of 1 plus 1. There is no square root because this is inner product. So 1 plus 1, that's 2, times V1, of course. Okay, times V1. So multiplied by -1, 1, and 0. So the answer is -1 plus half. So it's -half. And 0 minus half. So it's -half. And 1 minus 0. So it's 1. So I'll choose V2 to be -1, -1, and 2 if I multiply here by 2. So now let me check that V1 and V2 are orthogonal. -1 times -1 is 1 minus 1 plus 0. So in fact, it's orthogonal. And orthogonal also to 1, 1, 1. So -1 minus 1 plus 2, that's also 0. So V1, V2, and V3, which V3 would be 1, 1, 1 in this case, are orthogonal. But I have to make them orthonormal to form P. So the first vector, I'll put it 1, 1, 1, 1. To make it orthonormal, the length has to be 1. So I have to divide by the length. The length of this vector is square root of 1 plus 1 plus 1. That's square root of 3. So I'll have 1 over square root of 3, 1 over square root of 3, and 1 over square root of 3. So this is the first vector. Now, the second vector, which is -1, 1, and 0, V2, V1. Well, the length is square root of 1 plus 1, square root of 2. So I'll have -1 over square root of 2. I divide the vector by its length, and here 0. And the last vector is this one. The length is square root of 1 plus 1 plus 4, that's 6. So I'll have -1 over square root of 6, -1 over square root of 6, and 2 over square root of 6. Now check, verify that PT times P is I3. This is for you. Write PT. So 1 over square root of 3, -1 over square root of 2, -1 over square root of 6. The first row, you write it as the first column, and the second row as the second column, and the third row as the third column. And you multiply this by P, and this is P, and make sure that you will get the identity. This is to check that your answer is correct. Determine P inverse AP. P inverse here, because it's orthogonal, is PT. So P inverse is in fact this one, PT. Multiplied by A, write the matrix A, okay? And write the matrix B here, A please, and here B. When you multiply these two, you should get a matrix, diagonal matrix, where the diagonals are the first, this vector comes from where? From lambda equals -2, the eigenvalue. And the other two vectors are coming from lambda equals to 1. So when you multiply this 3, you should get this matrix. Also, you have to check your answer to make sure that your solution is correct. The eigenvalues of A10 are 1 to the power 10 and -2 to the power 10. So 1 and 1, 0, 2, 4. These are the eigenvalues. Compute A10. A10 is by definition equals to P times D to the power 10 times P to the power -1, or PT in this case. So write P and write, this is D. This is the matrix D. And so P, D to the power 10 would be -2 to the power 10, which is 1024. And here I'll have, and here multiply by P minus, and check that the answer would be 3, 4, 2, 3, 4, 1. So it is a symmetric matrix. You can do that by the calculator, checking that everything is correct here. Let T be the linear operator defined by this formula. Determine whether T is 1 to 1. Well, T is 1 to 1 if T inverse exists. And T inverse exists if we can find the standard matrix for T inverse. So let me first find the standard matrix for T. I have X, Y, and Z. Write the coefficients 1, 2, 3, 2, 5, 3, 1, 0, 8. This is the standard matrix of T. You can find the determinant to check whether T inverse exists or not. So the determinant of this matrix, you can find it by calculator also if you like. And make sure that you check that it is -1, different than 0. So T inverse exists. So T is 1 to 1. Find T inverse X, Y, Z. So I need to find T inverse, the inverse of this matrix. Either you put here a vertical bar, the identity matrix, and you do it by yourself, or if you know how to find it by calculator, you will find it -40, 16, 9, 13, -5, -3, 5, -2, and -1. So I can write T inverse X, Y, Z as this is X, this is Y, this is Z. So it would be -40X plus 16Y plus 9Z. This is the first equation, the first component. second component, and the third component. And you can check that your answer is correct, you didn't do a mistake, by finding T of a vector 1, 1, 1, for example, and then T inverse of the answer, and it should be 1, 1, 1. Consider the set W consisting of all polynomials P and P2 such that P1 is 0. What is the standard basis of P2? P2 consists, the vector space consists of all polynomials of degree less than or equal to 2. So the standard basis is 1, x and x squared. Give an example of a polynomial in W. Well, W consists of all polynomials such that P of 1 is 0. So when you replace x by 1, P would be 0. So Q, for example, a lot of examples. For example, x squared minus 1. Then Q of 1 would be 1 minus 1, that's 0. Okay. Or another one, 2 minus x squared. Q of 1 would be 2 minus 1 minus 1. It would be also 0. So this Q is in W and this Q is also in W. Show that W is a subspace of P2. W would be a subspace if we take any two polynomials, P1 and P2 in W, and prove that their sum and scalar product with each one of them is also in W. But first, what is the meaning of these two polynomials being in W? The definition of W is any polynomial in W has this property, P of 1 is 0. So P of 1 is 0, and also P1 of 1 and P2 of 1, both are zeros. Now, what would be P1 plus P2? P1 plus P2 would be in W if P1 plus P2 of 1 is 0. But what is this? It's P1 of 1 plus P2 of 1, but this is 0 plus 0, 0. So P1 plus P2 belongs to W. Also KP1, if we find KP1 of 1, is it 0? If it is 0, then it is in W. K is a constant, I can take it outside. And B1 of 1 is 0 because B1 is in W. So the answer is 0, so this means KP1 is in W. So W is a subspace of P2 because we proved that W is closed under addition and scalar multiplication. This was the last question. I hope you enjoyed solving the exam with me.